Okay, so Newsy, what is gravity, and does it pull things? Can you show me this gravity?
Hey, my English is not that good, so um, I don't know how to explain gravity. I think it uh pulls based on the mass of the object. I think.
That's never been tested or proven. That sounds like something that somebody made up. Do you have any experiments that would prove this?
How planets orbit around the sun and how satellites
What
works. I don't know.
this?
Yeah, something like that.
No, this is all pre-assumed. I need you to prove to me that gravity even exists.
You can assume things and test it.
No,
So yeah, I don't know how to explain it. Yeah, I don't know how to explain gravity. I think I have a language barrier. Uh, I learned most of
no.
those things in single language, different language. So yeah, I mean, can you tell me evidence? Give me evidence that Earth is flat.
Oh, it's measured that way by everybody in every major industry, and there's no curvature detected or measured anywhere on the surface of Earth. It's also everybody's primary experience when they go outside or do anything on Earth. Everything is a vertical and horizontal relationship everywhere. So there's no curve measured, there's no spin measured. There's four different vectors that the Earth should be experiencing, and you, by the way, which are not experienced or measured by anybody. And every major industry, including the quote unquote space agencies, aerospace, engineering, all that stuff. They are at surveying, navigation, all of them use the Earth and measure it and reference it as a flat plane.
I mean, yeah, Earth is big, so you can't detect it just by yourself. I mean, if you go outside, but
I
I
didn't
think you
say
could.
that. I didn't say that. Excuse me. I didn't say that, did I? I said it's measurably flat by everyone. I didn't say it's not it's so big that it looks flat. I said it's measured that way by every major industry. So if you could address that instead of something that I didn't say, that would be fantastic.
Um, I mean, yeah, the the the, the plane analogy because you have to. I'm not meaning you have to pitch up or down. I think the gravity. I don't know how to explain that, but I'm saying that you can't go in a straight line to travel to a country. You have to address the curvature, and
What curvature?
I'm saying that the directions. I mean,
What curvature
uh,
are you talking about? The curvature that's not measured or the curvature that is measured?
uh, yeah, I don't know much about that. Um,
What do you mean? You just told me that they have to fly over the curvature and now you don't know much about that?
no, I mean, uh, if you uh, uh, draw a straight line across through two countries, if you go that path, you can't go to the direction. You have to like curve it the the path, so you have then you
Well,
can go to that direction.
if it's curved, it's not straight.
What do you mean by that?
Well, you just said if you go straight to another country, and then you said there's a curve. Curved and straight are not the same thing.
Yeah, straight line doesn't exist on a globe. That's what I'm saying because
No, they
if
don't,
you
because the Earth is curved, and you can't do a straight line on a curve.
yeah, that's what I'm saying because you have to let's say I draw a straight line across Europe and um, New York, and if you
So
just
hold on
follow
before
that.
you say anything else. Before you say anything else, when you say straight line, you mean that there is no curvature in any axis. The x, y, and z axis is what we're talking about is an absolutely straight line. There's no curve. Is that what you're saying to me?
No, no. If you make a straight line that like that and follow that path, you would end up in a different place than what you expected to go by drawing that straight line. You have to curve the path
Drawing.
to
You
curve.
said we're talking about travel, not drawing. We're talking about reality. Are you talking about a map?
Yeah, I'm talking re- based on a map. Yeah.
Okay, so
So
a
if
straight
I
map, or it's a flat map, right? A map that we put on the table.
oh yeah, yeah.
Okay, so a straight
Uh,
line.
straight line to between two countries, and if
Okay, so
you
a flat
follow that,
Earth.
oh yeah, if you follow that path, you would not end up in the place that you expected to go, because you
What?
didn't address the curvature of the
What
uh
curvature? This is the thing that I'm asking you about. What curvature in reality is there that can be measured? Where is it?
give me a second. I'll give you a picture. I don't know how to explain. uh
No, I don't want an explanation. I want to know in reality, in the real world, on the earth where you live, not a map, not a concept, not a reification of the earth, in real life, where is the curvature measured to be? Where is it?
I think you don't need the curvature to.
What?
I mean, you don't need to measure the curvature to. I mean, if you want to go somewhere in a vehicle, I don't think you need to measure the curvature.
Bro, I'm not even talking about travel. I want to know if the earth is curving like a ball, because that's what balls do. They essentially curve and roll. That's two things that balls do. Curve and roll. We're talking about the curvature right now. That's one of the things that makes a sphere is the curvature. In reality, where can I find the curve of the earth?
Yeah, I don't know. Yeah, yeah, I don't
You don't
know
know.
much. Yeah, yeah, I
How
don't.
how
I
could
don't.
the earth be a ball if it's not curving?
I'm saying I don't know how to explain to you that it's a curvature curving.
I don't
Uh,
need an explanation. I want you to show me where the earth can be measured as a curving surface, like a ball.
can't you do some triangulating measuring to measure if
Well, that
it's
would be a
curving?
flat earth. Yeah, I mean, that's just a flat earth that you're talking about. Triangulation between points, straight line distances between points, that's a flat earth.
Is it?
Yeah, you can't have curved lines and make a triangle. That wouldn't be a triangle.
Yeah, I don't know how to explain. I'm sorry.
I don't listen, bro. I don't need you to explain something to me. I want you to kind of figure out that in reality, the Earth is not curving anywhere. No one ever actually treats the Earth as a curving surface, ever. No one measures any curvature anywhere, ever. In fact, when they triangulate between points to survey the land, they use flat, straight lines across the surface. They have to be really accurate. So they reference the Earth as flat and they measure it that way. And then on top of all this, probably the most simple thing is the water. Don't you and I both know that water is flat on the surface, right?
Yeah. I mean,
Okay,
you
so if
can't say.
70% of the earth is water, that's 70% flat. Is there such a thing as a 70% flat ball?
Uh, but the
What you're saying
gravity
doesn't
pulls
make
it
any
towards
sense.
gravity pulls it towards the earth, so it
No,
stays.
there's no
Yeah.
gravity. And plus, the surface of the earth or surface of the water is flat. So if the surface of the water is flat and 70% of the earth is water and it's flat, then you've basically debunked both gravity and the globe.
You are saying that based on gravity doesn't exist.
Well,
I
no
mean, if
one's
you
ever
jump,
shown me anything that you could call gravity. What is gravity?
I mean, if you jump up and you go down, what is it?
That's jumping.
Yeah, why are you coming down?
Because the earth, or well, the air doesn't support you. What if I jump in a pool? If I jump in a pool, am I going to go all the way to the bottom, or am I going to float to the top?
I don't know. It's based on the density, no? Because
Yeah, it is based on the density. So when I'm floating at the top of the water, what happened to gravity? I thought it was supposed to be pulling me down to the surface.
yeah, but the water is pulling you up, pushing you upwards because you have a lower
So
density than the water.
well,
The
the water
gravity
doesn't
is
push me.
the gravity is pulling you down, but at the same time, the lifting force is taking you up. So it
What?
just,
There is no lifting force. There's no
there
lifting
is a
force.
lifting. There is, like, what
No,
the
there
fuck?
isn't. No, you're just saying that. I want you to show me that there's a lifting force, and then I want you guys to tell me what gravity is so I can use it in an experiment and test things with it. What is gravity?
Didn't you debunk it with Earth curve measurements, though?
Gravity is a force that, existed with gravitons, and like it's possible
No,
to observe
no.
them
This is
in
totally incorrect. I'm going to stop you right there before you begin to embarrass
escalators,
yourself.
but
There's no gravitons. Sweetheart, can you please let it go? You're going to embarrass yourself. I need you to tell me what gravity is, get me a sample of it so I can use it in an experiment.
oh my god, it's like, oh, I'm not gonna talk,
Oh,
okay?
yeah, you're not going to
Sorry.
talk because I'm asking for things that you claimed, and then you're just making stuff up on the spot, which is fair. Everybody does this, but you don't actually know what gravity is. You were just told about what gravity might be. And I don't need to hear about what gravity might be. I need to know what it is.
You're seeing gravity in real life every day.
I don't see it anywhere. What does it look like? What color is it? Is it heavy?
You don't have to see it, you see what it does.
What does it do?
What does it do?
What does it do? Yeah, what does it do?
Yeah,
I'm
you tell
asking
us.
you. This is your claim.
I mean, I'm saying you're seeing what it does.
Where?
You're not telling me anything. Where? What? What does it do?
Oh my god,
Point to
like,
it doing
you're
something.
so ignorant.
No, we're asking you to give us an example of gravity doing something. So what's the phenomena you say is gravity, sorry, that gravity is causing?
So we know that there's no gravity
No,
in
don't
the
tell me what,
space,
no,
right?
sorry. Don't tell me what not gravity is. We want the phenomena in the physical natural world because you said it's all around us. Just give us an example.
Oh, okay, like, just listen to me. We know that in the space there's no gravity, like, you just float. If you go to space, you just float
You've been
in
to
water.
space, have you?
This isn't going to go anywhere,
Oh,
is
you're
it?
gonna say that
Sorry, hold
like,
on. No,
humanity
you
never
said
been
it
to
was
space,
all
right?
around us. You said it's all around us. And then you went to space where nobody's been. I thought when you said gravity, you meant when we're here on the Earth, it does things here on the Earth. I was hoping for an example of what it does here on the Earth.
Like, I mean,
No, you have to go to a place you haven't been
your
before and see it
items,
not doing something.
well, your items are not floating around. Like,
It's like I could give you an example. An apple fell from the tree. Would that be a good example of gravity doing something?
yeah, I'm just saying that, like, your
Yeah,
items
that's what we were waiting
are
for.
not floating around. Like,
We
if
didn't
there
want
was
the
no, if there was
my
no,
friend.
you're
My
not
friend, I
letting me
didn't want the
speak. You're
antithetical
always
claim.
interfering.
No, because I didn't want the antithetical claim. You're giving me what I didn't ask for. Asked for an example, like the apple falling. Something in the world around us that you said is clearly observable. That type of example.
So are you telling me that an apple falling from the tree is out of world?
It's on the world, something that we experience. So when we point at the apple, someone might question, well, why did that fall down then? Is
Okay,
there
can
a
you tell
force
me?
that pulled it?
Can you tell me when you jump, what takes you down?
We don't know.
Nothing.
This is the point of inquiry. You keep saying a word, gravity, and then you said gravitons, that's really outdated. So we're asking you.
You're asking me what? Like I'm giving you example.
When
like
you jump up, why you come back down?
yes,
What's that?
because of gravity.
Okay, what is that word? What does it mean? What does it do? What is it?
Does gravity only pull things down?
No,
it pulls things
Oh,
No.
so
together.
what else does it do?
like
What else does it do? Does it paint your car? Does it shine your
Make you go round
shoes?
and round.
It
it
pulls
gives the
things
shape of your
to
body.
it.
Sorry,
What?
wait, what?
Like if human race would have gone into another planet and lived there like
Holy
for a
shit.
couple of thousand years,
No,
maybe I
like
would say.
weird mysticism time.
In the end, because of the different
Why are we going into your
rate of
strange, weird
gravity.
mysticism?
Okay,
It's
listen
like
to
the
me. Like,
law
don't
of
interfere.
it's like
Don't
the law of the Jedi at the
interfere.
moment. It's really weird.
Don't interfere. What the fuck?
Interrupt.
It doesn't matter.
Yeah,
Listen to me.
Does.
yeah, if you're learning English, we're trying to help you. The word you're looking for is interrupt. But please do not bring mysticism and space travel into other planets with your weird ideologies. We don't need that. We need scientific validation of something.
Yeah, I'm giving a scientific validation to you.
Okay, great.
No, you're
So
not. You're giving us stories from other planets and what you think might happen to our biology and our form. That's not scientific. Science is
That's
based on observation.
scientific.
Sorry, hold tight, young lady. Science is based on observation of our physical and natural world, not your supposition about what happens on other planets.
Okay, let me tell you something. Like, do you know what is like quantum physics?
yes.
Quantum physics is like a mystery, you know? We can't really observe everything of it, but it actually takes a good place in today's technology, as you know. We
Okay.
don't
What does
have
that
to
have to do with the
observe
topic?
everything. We don't have to observe everything to prove them.
Okay.
We can prove them
So
theoretically.
no, you can't prove anything theoretically. Like, are you saying that theoretically Superman could exist, therefore Superman does exist?
I'm not
Are you
telling
saying
that
you?
because it's not proven theoretically. Okay?
Sorry.
It is
Are
proven
you saying?
theoretically. I have a formula for Superman. I have it in math. I can describe him with math. Theoretically, Superman could be real. So I think
Okay, describe
Superman
it
is
to
real
me.
because
Okay,
he's.
describe it to me.
Oh no, it's just an equation that I have. It's theoretical.
Okay, explain the equation to me.
Okay, well, S is Superman, right? And that equals R. R is real. Superman equals real.
Bro,
When you said that quantum mechanics exists and we don't understand it, is that you saying that you can't scientifically prove gravity?
no, you can't prove gravity scientifically. You can observe
Can you?
it.
Can you?
I mean, I can if you were near me, like we could have done a
Okay.
basic experiment.
Describe it to me then.
I'm not describing it to you.
Sorry. All you would have to do was at least give me the hypothesis. It seems weird that you don't want to validate your claim empirically with the scientific method when you claim gravity and we don't believe it and blah, blah, blah.
Okay, just just Google some experiments on gravity
Just
on the
Google some
internet
experiment. No, right, okay. This is a slight
and
heads
just
up. Been
watch
doing
them.
this. Been doing this for over 10 years. I'm 50 years old. I know that gravity, even from the preachers at the top, they don't even know what it is. There's up to 20 different ideas for what gravity could possibly be. At the moment, the most common theory is Einstein's bending and warping of space-time. Heads up, no gravitons in that. So there's lots of different ideas for gravity, but none have been scientifically and empirically validated with an experiment. That's the road that we're trying to lead you down. You, when you point fingers at us saying that we don't believe in this thing that you do, we've got reasons for it. It's not scientifically validated. If you knew your own rhetoric, you would understand that.
Okay, if you say so.
Sorry, I do. What have gravitons got to do with Einstein's bending and warping of a space-time fabric? What gravitational theory do gravitons come from? Would you not like being challenged on the stuff that comes out of your mouth?
Okay,
Yeah, like take for instance,
I just think that like we're in separate thoughts. I don't see any like it doesn't make much sense to me to try to prove this to you because
We
it's
know you
waste of
can't.
time.
Why?
you can't prove it.
Why do you think it's a waste of time to have your beliefs challenged?
My
Let's
beliefs are
put it like
not
this, right?
changed, but
Let
I'm
me
not
put it like
interested
this.
in changing your beliefs. Okay, you can't.
Yes, no one should be. Let me put it
Yeah.
like this. Right at the beginning of Says Who's statement, he says that the surface of the Earth is measured flat. Now, if you're going to bring up a gravitational story that attracts everything to the center of the Earth, making the Earth a planet, then you would understand that if the Earth was a planet, it would be curved upon the surface. The measurement of the surface of water, the thing that you drink and bathe in every single day, I'm sure, the surface of water being horizontal debunks the claim of gravity pulling everything into the center of mass, forming a planet. You should have stopped there and asked him about that.
So you're also saying flat is Earth, right?
Water,
No,
primarily.
like let's say, mm, let's say Earth,
Okay, so the
water.
planet Earth or the Earth that we stand on, like the rocks and the mud?
So
Capital or lowercase
you're
e?
claiming that it's fully flat, like, right?
Horizontal.
So I want you to go to different cities.
Mm-hmm.
At least like there must be, let's say, 40,000 kilometers distance. Okay.
40,000 kilometers. Are you going to say that if the Earth was flat, then you should be able to see that city that's
No,
40 kilometers away?
let me explain, please. Let me finish.
Okay.
So, okay, I want you to um use a stick. Put the stick at the same hour in those cities and just measure the the length of the shadows. Okay,
Okay.
you're gonna see that they're
Oh,
different. You're gonna see that they're different. How can you
Okay.
explain the difference?
Because you're
What
not
are your
underneath
thoughts?
or local to the light source. If I was to stand underneath the light that's in my living room at the moment and put, let's say, a stick in the floor, then there wouldn't be any shadow cast because it's directly under the light. If I was to pick that stick up, walk away from being directly underneath the light source and watch my shadow increase in front of me, my God, shock horror, and then stuck the stick in the floor, I've noticed there's a shadow because of the angular relationship from the light source that's above on my ceiling to the stick down below. Now you've got two sticks, right, that you've placed on certain locations on the Earth, two cities. I presume that they're on the same line as longitude, you said, at the same time. I presume one of them will be directly underneath the sun, let's say. Another one would be, I don't know, maybe 500 stades away, like in Alexandria, for example. You put a stick in the floor, an obelix, if you want to speak about some Greeks, and notice there's a shadow. I mean, you can do this on a flat surface. You're just not underneath the light source when you cast a shadow.
Okay, never mind.
So, did you not understand that?
No, I got your point.
Okay, so
But you can only explain this with the
with
difference, with the angle.
angle.
And
Sorry,
this
what's an sorry. Explain the difference of an angle. What do you mean? Explain the difference. What does that mean?
No, I'm saying, like, the length of these shadows are different, right?
Well, yes. If
And the
I'm
difference,
Oh
underneath
my
my light
gosh.
and the
with the
reason
stick in the floor,
behind.
there is no length of shadow. If I was to walk 2 feet away from being underneath my light source, there'd be a short shadow. If I was to walk further away, there would be a longer shadow. I don't understand what's hard to explain. The length of shadow is representative of the angular relationship between the stick and the light source. You've played shadow puppets before, haven't you? You're talking about shadows.
Yes. And why
Yeah.
don't you think that there is, like, this causes because of the different angles because of the shape of
No,
Earth?
it's because you've moved your relationship to the light source. I mean,
I
let's put it like
can't.
this. It
I
wouldn't matter
cannot.
if the surface was curved or flat. If you're underneath the light source, you're not going to cast a shadow until you start walking away from being underneath the light source. And you can watch your shadow increase in front of you. Right?
If the world,
Young lady,
if the
if you
Earth
could
were
look in the
flat,
side chat at 10 minutes after the hour, please look in the side chat 10 minutes after the hour. We're going to show you that lengths of shadows prove nothing.
okay, I'm gonna tell you something. Like, if the Earth were flat, the shadows would be the same.
No, they
The only
wouldn't,
thing,
because what is everybody
the
underneath the light
difference,
source?
the difference in the angles,
No,
you know,
incorrect.
only makes
Why are you
sense
not looking at
when
the
the world
example?
is
Why?
curved.
Excuse me.
When
Why
it's
are
It's
you being
weird.
so
curved.
rude? Can you
I'm
Why
please
not
do
look in the
being
side chat? We're
rude.
trying to help you out. We're trying to help you. The length of the shadows makes zero difference as to the ultimate curvature of the surface of the Earth. It really doesn't.
No,
It can
it
be
makes.
done
It
either way,
makes.
curved or. Well, then look in the side chat. You tell me which one is correct: the curved Earth or the flat Earth.
it's really weird
Yeah, have a look in the side chat.
Javen.
to say if the earth was flat. What do you think? Everybody would be underneath the light source, no matter where they were on the earth. This is observably not the case. This is why we have shadows. It's really weird you said that. You must understand our flat earth position doesn't make the sun bigger than the earth. So you think that all positions, when you stand underneath the sun, there's not going to be shadows cast because the sun is bigger than the earth. No, observably, we're just getting angles from the sun, and my goodness me, the shadows are caused by things that are intersecting that light. Interesting phenomena. Doesn't prove the surface is curved.
Yeah, you got to stop thinking that your opponent has no idea what they're talking about. And when they're
Okay, can you
attempting
tell me
to
something?
I'm just talking, and when they're attempting to refute something you've said, you must listen to the refutation and try and understand it, just in case you're in error.
Okay. So,
So
Jedi, you
lengths
were
of
telling
shadows
me
prove nothing.
that. Okay, so Jedi, let me explain.
Yeah.
Let me give you another example. Like, I want you to explain. You were telling me that the water is flat, right? At the
Yes.
beginning. So, if the water is flat, then, like, why we lose the sight of ships when they go far away? Why we lose the bottom's side of ships? You know,
Good
why we
question.
can't see it? Why we can't see it anymore?
Good
Like,
question.
yeah.
Yeah. So first of all, you must understand that when you were standing at the beach and you watched a boat go away, the reason why it appears to get smaller is just because of perspective, right? You understand that bit.
No, I was talking about like
I know.
if the Earth
I'm
was
going,
if the
my
Earth
friend,
was
my
flat,
friend,
you know.
yeah, I know. If the Earth was flat, I'm going to walk through this slowly so you understand. You may understand some of the stuff I'm already saying. I'm not patronising you. I just want you to understand. It's going to take a little bit of your time for me to explain this to you. So, firstly, you understand that when things move away from you, they appear to get smaller, don't they?
That wasn't what I was asking.
Yeah,
But
you're talking
yes.
about the boat. I know. Why
You
can't I
know,
see the bottom of the boat? Why does it
yeah,
appear
like
to look like it's going down?
This one's not familiar with the Socratic method, obviously.
No.
first the bottom is becoming invisible, then the upper part. Like if the Earth was flat, it would be like at the same time. You know what I mean?
Yeah, I understand. See, you understand firstly where I'm coming from. Why the boat appears to be coming upwards, right? Because it's increasing in angle of sight as if it's coming towards you. The reason why you can't see the bottom of the boat is one, perspective, but two, it's probably to do with the meteorological conditions that you're looking through. There are certain things called atmospheric refraction. One of them is termed sinking. Now, this phenomena called sinking makes it look like the boat is sinking beyond the horizon. The explanation for this, when we read the terms, is there is a direct line of sight between you and the observer. Sorry, between you, the observer, and the object. A direct line of sight, meaning there is nothing in the way. Due to the meteorological conditions, it appears to make the boat look like you can't see the bottom of it. Now, the meteorological conditions alone can explain many phenomena that we see with boats far away in distance through multiple miles of atmosphere. It can make the boat look bigger. It can make it look like it's floating in the sky. It can make it look like it's reflecting underneath. It can also make it look like we can't see the bottom of it. But those will just be the meteorological conditions.
Okay, I got another question to you. Like, okay, if the Earth was flat, you know, um, like there should have been like a beginning and an end, like, you know, but there's not. Like when you start walking from a point, like point A, and if you just don't change your direction, while you're on the way, you will find yourself again in point A. And how do you explain that?
You don't always end up where you started from if you go in what you call a straight path in no direction. But I understand what maybe you're trying to get at when you said the beginning and the end of the earth. It's weird, right? You think the earth is a sphere and you're always going to end up where you started if you just go in a straight direction. When confronted with us saying that the earth is flat, you start asking the questions, well, if I keep going straight, obviously if I'm inside the system, I'm going to reach the outside of the system. So what's the edge like? These types of questions. So what do you want me to answer first? Do you want me to answer why you're not going to find it when you keep going straight? or what the edge is like? What one do you want to know?
You can start from the first one.
What, walking straight? Hello?
Hello?
Yeah, walking straight or the edge, which one?
Okay, the first edge, then the walking straight.
So the edge, it's a weird concept. I wouldn't be able to tell you. Never been there, wouldn't know what it was like. Some people think the edge is something that you would fall off of into space. Definitely don't think it's that idea. There's no space to fall off into. Some people say that we're in a contained system, some type of limitation, like I don't know, a boundary or some type. I don't know. These are all speculations, though. The idea that maybe there is a limitation to our reality, and what is at that limitation or beyond it, we have absolutely no idea. Going straight thing, that's not always the case. So if you were to travel east or west, those aren't straight directions. Those are 90 degrees to north. So if you were to keep traveling, you'd have to alter your course to be 90 degrees to north when traveling east or west. So that would be a circle around the pole. Traveling straight lines would be following like the equator, or like a line of longitude, like from the north to the south, or any type of total circumference of the earth. The north and south ones aren't done. East to west ones, circles around poles, they're done every single day. When we talk about circumnavigation, that's just circling around a pole. But circling through poles, north, south, and back, following one line of longitude, I dare anyone to go find one verifiable flight or voyage that's done that. That doesn't happen. But yeah, you don't go straight anyway. It's hard to do so, especially when you're following directions and cardinals and east and west and stuff. If you've got any other questions, I'm sure there are lots of other people that can answer them as well, not just me.
Oh, no, I don't have any more questions.
Do you want to know how we know the Earth is flat?
Not really. I mean,
Really?
I think you're very well aware that it just doesn't make any sense for me, because it's just the opposite of I know for sure.
Hmm.
Yeah.
I was the same 10 years ago. Seemed a really weird idea. But it is what it is. It's measured to be flat.
Yeah, I'm saying like it's measured to be curved.
Then you would have to provide the measurements to back that claim. In reasonable conversation, if you say that I think this, that the measurements show that the Earth is curved, then we would ask you reasonably, well, what measurements? How were the measurements done? What tools were used? What curvature rate was measured over what distance? Those would be the reasonable questions, because those are the ones that we've answered.
Yeah. You'd have to show that there's a change to the Earth's surface in the y-axis, right? As it travels along the x-axis. You would find the curve that way, right? Not by saying, look at this shadow here, or pointing at the sky and saying, look what the sun does, or anything else, right? Just measure the surface. Show that it has deviation from horizontal over distance. You think you can do that? How many surveyors measure shadows?
Oh, all of them. Daily.
Do they though? Do they actually measure shadows?
Probably not, indeed.
Yeah.
I